Hello guys, welcome to my YouTube channel. So today I am going to explain you polynomial regression. So in my previous video I explained the polynomial regression but only one input variable, and in this video I am going to explain you the complete setup of polynomial with multiple inputs. So with the help of Kaggle example I download this database. You can see that I am importing the Kaggle library and using this dataset like manufacturing data for polynomial regression and things like that. So I am just explaining you also need or you also want to learn things, right? Because the polynomial regression is one of the most important concept in machine learning. So now you can see that I am just importing the data set. Now I am importing some libraries which is called pandas, numpy and matplotlib. Then I am just using the df or just reading the data set using the pandas, and now I am doing like printing some first five rows of the data set using the df add function. So now you can see that I am using the like checking the null values, is that any values present or not in my data. I explained this thing in my previous video like how we can check null values and things like that. Also I am giving some like random summary, but in my previous video you can watch there and see how I am completely doing the statistical analysis on my data. So now I am just printing the columns using the scatter plot. So you can see that in my data structure temperature has the negative correlationship with my output variable. So here my output variable is the quality rating and my input variable is like temperature, pressure and all the things. Now also you can see that my pressure has the no correlationship between my output variable. There is nothing, there is no any curve like this one or this one and things like that which are present, so we can say it's a no correlationship. But if I multiply temperature into pressure, so there is some correlationship, right? There is some negative correlation which we can observe that on my magnifying data. After we can do the temperature and pressure cross product. So now again material fusion matrix has some negative correlationship and the material transformation matrix has also the negative correlation. So you can see that I am just using the correlation function as well to print the plotting the actual parameter or plotting in the numerical value. You can see that the quality rating here which contain have the negative correlationship. In this you can see that pressure has the no correlationship. In the temperature into pressure has some negative and things like that. So after that I am just importing few libraries which are required for us to doing the analysis. So in that we can say that train and test split, also polynomial feature, linear regression and mean square error. Now I am just splitting the data into x train, x test, y train and y test to just doing the analysis. So I am using the 80% data for testing and 20% data for the testing, and also shuffle is also true because to remove the biasness we use that. So now I am just printing the size of all these parameter because size is important to see like what going on in my data. So I am just using the size here. We can see y train dot size, or we can see shape. Actually shape is important, size is contain the number of cells. You can say test dot shape. Now you can see that I have like a 5 column which are present in my input variable, and x test also has the 5 column but the rows which are differ, and also I have the matching row with my x test and y test and my matching rows with my x test, y test and x test. So x train and y train match the row count and x test and y test match the row count. So now let's do our first job is like polynomial regression. Let's fit or let's transfer our data to for the linear regression using the polynomial regression. So how we can do that? We can use the poly feature here, polynomial feature. I'm just initializing it, then poly dot fit, and we use the transform method. I explained these things in my previous video why I use transform method and things like that. So now we can need to convert my x train into polynomial feature. So before that I just use here the x poly using adding one variable because this variable is required in my again counting or calculating the output. So you can see that I am just assigning my x poly to x train. So in polynomial regression we have to convert only input variable, not the output variable. Output variable conversion is not required, you just have to use the output variable as it is. But input variable you have to convert that, because this data has the straight line curve and I want to curve like something like negative correlation and curve like structure. So that's why I'm using the polynomial regression to fit my data. So now you can see that okay, my transformation is done. Now we need to implement regression. So regression equal to linear regression. Now we can say regression dot fit method, then we use x poly as an input, comma y train as for the training data. So now you can see that it's train my algorithm based on the input feature and the y train. So now let's predict something. Let's predict our test cases or test output. Now you can see that, but before that we miss one thing. What is that? In the polynomial regression you can see that there is a degree variable, which is very important. What the degree you should use for this? Because degree, which means, actually I explained this in my previous video, degree which means like you actually define how much like you can see here the definition as well. Input variable is that like something like that, but in the easy way I will explain you. Degree which means like the how many your variable or your input data, how much you will convert or how much degree you want to assign to your input data, which means that your equation of the line y is equal to mx plus c in the polynomial, in terms of the polynomial regression, will become the y raised to 4 and something like that. So you can see my previous video where I explain everything regarding that. So the regression dot, we can say use the fit method, and I'm just assigning the my you can say regression dot predict method. Here I need to use the predict, and we can use, but before I want to giving the x test directly, I need to convert this as well into polynomial. So we can use the same thing like polynomial fit transform, but I am just using here y x test, comma. So here you can see that, and then we can assign y predict equal to regression polynomial things. You can see that I am just transforming my test data into polynomial regression and then predicting based on the y. So y predict will be the prediction of these things. So now you can see that I have already with the y prediction, and also I have already with the my y test as well. Let's compare those things and see like what the error output it is giving me. Also let me use mean square error method. So what is the mean square error method? Is like y test means the actual y into, and another parameter is like y predict. So you can see that my mean square error is 13, right now it's 13 because I didn't give any degree here. But if I increase the degree here, my variable or my error will be reduced. Let me see you how we can do that. Let me put the degree equal to 3. Now I am just using or running those things. So you can see that before my degree was 13, right now my degree is 4. So I am reducing, means my equation will split into multiple degrees. So in that way my error will be reduced and my model is learning fastly and effectively. So let me fine tune here the degree to 4. You can see that I am just using the 4. You can see that after I am using the 4 degree, my mean square error again reduce and become to 1. Now you can see we can use the 5 here. You can see my mean square error will be reduced to the 0.4, which is like good prediction. This is the final one and this is the good prediction. Let me use 6 as well. What happened? What this? After using the 6, you can see that my error also reduced. Let me use the 7. Now you can see my error will be reduced and close to, actually very close to the 0, right? Means my mean square error will be close to 0. But if my mean square error will be 0, then this will create the problem of overfitting. So we don't want to make the problem of overfitting. So let's keep 6 here to make sure my error will be feasible, it will not arise as the problem of overfitting or reduce the problem of overfitting. So this is the way that we can implement the polynomial regression with multiple variables. So I am just passing the multiple variable to the degree to the fit transform method as a xtrain, but I am fine tuning the degree because number of input variable is increases. As per that we can increases the degree as well, because it's splitting my, or it creating the equation based on the polynomial regression. There is the mathematical analysis for this. You can try or google it, so you can learn more regarding that. But this is the actual implementation, and company wise as well, people are using same thing in the company or in the many companies as well. So that's pretty much for the polynomial regression side. Thank you so much.